Okay, so for this video, we'll be discussing paper 3 from October-November 2023, paper 3-2. So let's start with question number 1. First of all, they want us to sketch the graph of y equals to 4x minus 2 modulus. Okay, so to sketch the graph, usually what I do is like I try to sketch or try to imagine the original graph first. So the original graph, I'm removing the modulus first. Okay, so when I want to sketch this linear function without the modulus, basically you can try to find out what we do last time is we try to find out the x-intercept and also y-intercept. So to find out the x-intercept, I'll let y equals to 0. So from here, I get my x equals to half. Okay, and after that, if I let x equals to 0, then I will get my y-intercept. So my y-intercept is actually equals to -2. Okay, so for one linear line or one linear graph, basically it is enough for you to have 2 points. Okay, so once you have the 2 points, you can actually draw the the linear line. Okay, so I'm having x equals to half and y equals to 0. So what I want to do is like maybe I will want to put it like this. So 1, 2, 3, 4. So this is a half. This is a 2. Okay, so that means this is 1, this is 3/2. Right? Same thing happen for the y. Okay, maybe the axis is not long enough. I will put it longer. Okay, so this is half, then 1 and 2. Simply happen for the y-axis at the negative side. Okay, so I'm having -1 and also -2. And after that, the left-hand side, so I didn't label it. Okay, then according to what we have here, we are having the x-intercept half and 0. Okay, x-intercept is half, so that means it's this point. Alright, then I'm having y-intercept -2. So if I want to sketch the original graph, this is my y-intercept. So this is my x-intercept. So when I want to join these two lines together, so basically it should be something like this. You can use a ruler to join these two curves together, these 2 points together. Alright, so use a ruler, yeah, because I didn't use a ruler, therefore my line is not straight. But basically if you use a ruler, then it should look something like this. Okay, then for your information, when we want to put modulus sign, okay, when you want to put modulus sign to any original curve, basically it means that we are going to reflect the negative part of the graph become positive. So what is the negative part of the graph? Negative part of the graph means it is the part where the graph is below the x-axis. So I highlight the yellow color here. This is the part of the graph where it is below the x-axis. So when I put the modulus, I want to reflect it become positive. So how to reflect it become positive? So the negative y equals to -2 here, we will reflect it up become +2. That means my y-intercept for modulus graph will be this one. Here. Okay, so I reflect the -2 become +2. And now I use a ruler to join these 2 points together. Okay, so by right, you should be seeing that your modulus modulus 4x minus 2, right? You should have a graph like this. Oh, sorry, I cannot draw it properly. So I try my best to draw it properly. So this is a graph, the straight line. Alright, so assume that it is a straight line, you use a ruler to join the point together. Okay, so the original graph, you should erase it. So basically, this is a V-shaped graph for a modulus linear function. Alright, so for me, usually when I want to sketch the diagram, what I do is that I draw the original graph first, then only I reflect up the negative part become positive. Okay, when I put the modulus sign. So this is how I sketch modulus y equals to modulus 4x minus 2. Then let us proceed to part number 2. So for part number 2, they want us to solve the inequality. Alright, so to solve this inequality, there are many different ways. Some students might want to use graphical method, some students might want to use square both sides and so on. But no matter how, you can use the method that you used to. For me personally, I find out the critical value first. After I find the critical values, okay, for the inequality, for the equation, then only I will check part by part to get the final answer. This is what I do usually, okay, part by part. Okay, so you need to check part by part, especially when you are having the equation or inequality, one side with modulus, the other side has no modulus but with the x. So this is a type of equation that or inequality that you have to check your answer part by part. If let's say you're having one side got modulus function, one side got maybe a number, a pure number, then you can directly find out the answer, okay, by squaring both sides whatsoever lah. But when you're having this kind of question, okay, one side with modulus, the other side no modulus but with the unknown x or variable x, then you have to check the answer part by part. So this is a small reminder for you all, okay? Alright, so let's start. For me personally, I want to find the critical value first. How to find the critical value? So basically, I will make the inequality, I will ignore the inequality sign first, I'll put it as equal sign. So I'm having 1 plus 3x. For the modulus function here, right? Basically, you can write become two different parts. One part is 4x minus 2, another one is negative 4x minus 2. This is a non-modulus form for a modulus function. So I will let 1 plus 3x equals to 4x minus 2. So the other side will be 1 plus 3x equals to negative 4x minus 2. Then I try to get the critical value from these two equations. Right, so I'm having x equals to 3 for this equation. And then for this one, I'm having 1 plus 3x equals to negative 4x plus 2. So by right, you should be having 7x equals to 1. And therefore, your x is equals to 1 over 7. So these two values are the critical values that I mentioned just now. Okay, so for the critical value, I will always put it equal sign first. So I'm not going to consider the inequality first. Okay, after I get the critical value, then only I'm going to check my answer part by part to get the answer that I want. So how to get my answer part by part? So basically it's like this. I'm having two critical value here, right? So I will draw a number line for me to check it easier lah. So I'm having 1 over 7 and also a 3. So I separate into three different parts. One part is x smaller than 1 over 7. One part is between 1 over 7 and 3. One part is greater than 3. Right, then we'll check the answer here. So to check the answer here, for the part x smaller than 1 over 7, you can use any value that is smaller than 1 over 7. So for me, I maybe use x equals to 0. When I use x equals to 0, I substitute into my inequality and observe what is the value that I get or inequality that I get. So 1 plus 3 times 0, I get a 1. Okay, then smaller sign, I just put it as a smaller sign. Okay, so 4 times 0 minus 2 is negative 2. Modulus negative 2, you're having positive 2, right? So if you double check, 1 smaller than modulus negative 2, this is a correct inequality, so you put a tick. Okay, then after that, for the center part here, the second part here, I want to use a value that's between 1 over 7 and also the 3. So maybe to be easier, I will use the value x equals to 1. Again, substitute the value x equals to 1 into the inequality. So I'm having 1 plus 3, which is equals to 4. Put the inequality sign smaller. Okay, and then substitute 1 into the right hand side here. I'm having 4 minus 2, which is a 2. So modulus 2. Okay, so you double check the inequality. 4 smaller than modulus 2. It is a wrong inequality, so I put a cross. And after that, for the last part here, I will use any value that's greater than 3. So maybe if you want, you can use a 4. So when use x equals to 4, substitute into the inequality again. So 4 times 3 is 12. 12 plus 1 is 13. Then put a smaller sign. Modulus, okay, so 4 times 4 is 16. Minus 2, you got 14, right? So you're having modulus 14 on the right hand side of the inequality. Then again, double check this inequality and see whether is it true or not. So 13 is smaller than 14, and therefore this is the correct part that you want. So after I checking part by part, right, then I want to decide the final answer for this inequality. So from here, you can see that the answer is x smaller than 1 over 7. I only take the answer which is having a cross, having a tick. So smaller than 1 over 7, and also x greater than 3. So this is basically what I have for my final answer. Okay, so for checking part by part, the solution for part by part here, right? If you don't show it in the solution, it's okay. All right, because there are many different ways that student can use can solve this question. So either you want to show the graph also can, or either you want to show your solution by squaring both sides also can. But again, before you decide the final answer, make sure you check your answer part by part for this kind of inequality or equation. Okay, so this is how we solve question number. Okay, so come to question number 2. We are given the parametric equations for a curve. So these are the parametric equation. for t greater than 0, find the gradient of the curve. So again, highlight the keyword gradient of the curve. Basically, this one means dy dx. So you want to find out the value of dy dx. Okay, so when t equals to e means e power 1, simplifying your answer. So to find out dy dx from a parametric equations, right? For the parametric equation, this one, if you want to differentiate, you can get dx dt. Then for this equation, if you want to differentiate it, you will have dy dt. It is in terms of t, right? Okay, how can I convert them become dy dx? So to get the dy dx from parametric equation, basically you need to use the chain rule where dy over dt multiply with dt over dx. Okay, so this is what we're going to use later, right? Okay, so let's start with the parametric equation first. So I'm having log x equals to ln d power 2, the whole thing power 2. Okay, so first step, try to find out the differentiation of x in terms towards the t. So you're having dx dt. When I'm having a bracket with a power outside, so the process of differentiation will be you pull the power in front, which is a 2, copy the bracket, then power minus 1, which is a 1. Okay, it is very similar to what you had learned in AS before. And after that, differentiate the thing inside the bracket. Differentiate ln t, you are having 1 over t. So simplify this equation, you're having 2 ln t divided by t. Usually for me, I prefer to put it in a fraction form so that it is easier for us to simplify the equation when we want to apply the chain rule later. Right. Then let us continue with the second equation. So I'm having y equals to e power 2 minus t squared. So again, I can find the differentiation of y towards the t, so dy dt. I'm having the function e. So when I'm having a function e, right, the differentiation of a function e is you copy back the original thing, then you differentiate the power. When you differentiate the power, differentiate a 2, you get a 0. Differentiate negative t squared, you're having negative 2t. So if you rephrase it again, you're having negative 2t, then e power 2 minus t squared. Alright, then next step. So next step, we are going to get dy dx. So like what I showed you just now, dy dx, to find out the dy dx, you have to use the chain rule dy over dt multiply with dt over dx. So what is dy dt here? So dy dt is this equation. So this expression, negative 2t e power 2 minus t squared. Then dt dx, I'm having dx dt in this fraction. So dt dx means you have to make it upside down. So I'm having t on top divided by 2 and then ln t at the bottom. Okay, then we slowly simplify them. I'm having 2 and 2 can be simplified. Okay, then I don't think that anything else I can further simplify. Okay, so what am I going to do now is we are trying to multiply them together. I'm having negative t squared e 2 minus t squared divided by ln t. And they are asking us for the value of the gradient, right? So to find the value of the gradient at t equals to e, that means you need to further substitute t equals to e in your calculation. So negative, I just copy. T squared become e squared. Because t equals to e, then you're having e 2 minus t squared means e squared. Okay, then after that divided by ln t. So ln t means ln e power 1 because t equals to e. Okay, then after that, for your information, ln e power 1, if you press calculator, it is actually equals to 1. Okay, then for the numerator, right, e power 2 multiply with e power another thing, you can use the concept that we learned earlier, okay, where if you have a power m multiply with a power n, it is equals to a power m plus n. So I'm going to apply this at the numerator. So I'm having e power 2, negative e power 2, and multiply with e power 2 minus e squared. That means I'm having 2 power plus power. Okay, then divided by 1. So if you further simplify it, you're having negative e power 4 minus e squared. Okay, so basically this one can be my answer already, right? But if you prefer to change it into other value or maybe a 3 significant figure answer, you can try to press calculator and get the value. If you didn't do it with careless mistake, right? So by right, yeah, the 3 significant answer should be 0.0337. Okay, so this is how we solve question number 2. For this question, they didn't mention what kind of answer should you leave it as a final form. Alright, so it is not wrong that you leave it like this, or you want to change it become 3 significant figure answer. So some students might want to keep it in a fraction form in terms of e also can. Alright, so that's all for this question number 2. Alright, so now we are at question number 3. We are given a polynomial denoted by px. So it is given that it is divisible by 2x minus 1. So the keyword divisible actually tells you that 2x minus 1 is a factor for the polynomial. And when a polynomial is divided by the factor, right, that means you are having a remainder equals to 0. Okay, then after that, when px is divided by x plus 1, the remainder is 12. So the x plus 1 here we call as divisor, and we are having the remainder 12. Then for this question, they want us to find out the value for A and also B. Okay, so generally they are giving you these two information here, and we can use the factor theorem and also the remainder theorem to get the answer. So first of all, because we are having this 2x minus 1 is a factor. So according to factor theorem, I know that if I try to substitute half, okay, into the polynomial, I will get the remainder equals to 0. So I will get equals to 0. So how I get the value half? So the value half actually we can get it from the 2x minus 1. So you let 2x minus 1 equals to 0, and therefore x equals to half. So that means if we substitute x equals to half into the polynomial, the remainder is 0. So it is equals to 0. Right? Okay, so from here we can form one equation. So I try to substitute half into the x. So I'm having 2x power 3. So 2 half power 3 plus a, then x squared. So half square minus 11 half. Okay, then plus b equals to 0. Okay, so from here, if you try to simplify your equation, you're having 1 over 4 plus 1 over 4a minus 11 over 12, also 11 over 2, then plus b equals to 0. So I might want to keep my equation b in terms of a. So simplify everything, I have 21 over 4 minus 1 over 4a. I will make this as first equation. Okay, then after that, I will get second equation from the second information here. When px is divided by x plus 1, the remainder is 12, which means that if I want to, I can apply the remainder theorem in this case. When I substitute p negative 1, I will get the remainder equals to 12. So p substitute negative 1 equals to 12. So the 12 here is the remainder. How I get the negative 1? So the negative 1, actually you get it from the question here. Again, so we will let x plus 1 equals to 0. And from here you get x equals to negative 1. So that means if you substitute negative 1 into the polynomial, it will be equals to the remainder 12. Just now it's remainder 0, right? So now it's remainder 12. So again, from here you will get the second equation. So I'm having 2. Negative 1 power 3, then plus a, negative 1 square, minus 11, negative 1, plus b equals to 12. Okay, so simplify my equation here. Okay, if I didn't do any careless mistake, by right I should have negative 2 plus a, then plus 11 plus b equals to 12. So b equals to 3 minus a. I'm having this as the second equation. Okay, so since I successfully get two equations, okay, from the information provided in the question, and now I can solve them simultaneously to get the answer. So I will let 1 equals to 2. Okay, so 21 over 4 minus 1 over 4a equals to 3 minus a. Okay, so from here, very easily, if I try to do some simple calculation, right, my A should be equals to -3. Okay, so you can try on your own and see whether you make any careless mistake or not. So after I get A equals -3, I try to substitute into either one of the equation. Either one also can. So I substitute into the second equation. So very easily I will get the value for B, which is equals to 6. Alright, so this is how we actually get the value for A, so B. Okay, so now we are at question number 4. They want us to sketch on argon diagram, right, that fulfill the shaded area or the region that fulfill the two inequality. So the first inequality is this one, and also the second inequality is this. Right, so before we sketch, basically we need to rephrase it into the pattern that we are having the modulus z minus a complex number smaller equals to 2. So what's the complex number that I should put here? It should be 4 plus 3i. So that when you multiply the negative, inside the bracket, okay, then you're having -4 minus 3i. But when you want to sketch the inequality, we need to have the standard pattern where it should be z minus a complex number. So if you look at this inequality, basically it should be a circle. If let's say you draw equal sign, it should be a circle, which means that the distance from z to the point 43, the distance is always equals to 2. Okay, so it will be a circle for this inequality here. Okay, so you can try to sketch it by labeling your diagram clearly. Okay, so because this is a circle, right? So you should know that the center of the circle is actually 4, 3. And the 2 here basically is the radius. Okay, then so I need to try to plot and get the scale for my x-axis and also the y-axis. So I think I should have 1 until 6 to fit my circle in. Okay, so my center is 4, 3. So 4 is here, 3 is here. And then the radius is 2, right? So the radius is 2 means that by right, the circle will pass through this point, then pass through the 5 and also the 1. So if you try to draw a circle, it should look something like this. Okay, so my one might not be so circle, right? So if you can, you try to draw the circle as nice as possible in the exam if you can, right? Then after the circle, because of this inequality, they said smaller equals to 2. If I draw the circle on the circle itself, on the circumference itself, it is equals to 2. And they are not asking for smaller equals to 2. That means that by right, you should shade the area inside the circle, the whole circle. All right, for this inequality. Then after that, I'm having the second inequality where the real part of z is smaller equals to 3. What's the meaning for real part of z? For z, right, we are having a complex number. It is a complex number z plus x plus yi. So the real part of z means the real part is this one. The part with the I, we call it as imaginary part. So RE means real. Real part of z means the x. So in short, yeah, this inequality basically means that you're having x smaller equals to 3. Okay, so before you shade the area, try to have a look for x smaller equals to, x equals to 3 first. How you sketch a line, x equals to 3. So by right, your line x equals to 3 should be this line. This is a line, x equals to 3, it is a vertical line, right? And they said x smaller equals to 3 means that you should shade the area, okay, on the left-hand side of this line. And for the area that fulfill both of the inequality, you need to look for the overlapping area that you shade just now. So the overlapping area, very obvious, is this part. Okay, so there's a part inside the circle, okay, this part, where basically it is the overlapping of the two shaded area. Okay, so I need to show the final answer here. So the final answer for the shaded area should be this one. Okay, yeah. So this is how we answer part A. All right, then let's have a look for part number B. For part B, they want you to find the greatest value of argument z for points in this region. So again, argument z means that you want to get the argument, okay, of the complex number z from the point 0 plus 0i. Alright, so that's the meaning. Okay, what is the largest argument that you can get? Okay, for the complex numbers from the point 0 plus 0i. So we have to refer back to our graph just now. Okay, so 0 plus 0i means here. Okay, so you can actually use your ruler, right? You try to draw a line, okay, and then you try to use a ruler to move the line up until the last point that your ruler touch the shaded area. Okay, so you should move up slowly, because if you move up, right, then the argument here will become larger. Alright, so they want to get the largest or the greatest value of the argument. So if you try to move this line up by using your ruler, but your point fixed at 0, 0, so by right, you will have the last point that touch the circle somewhere here. So I label this as Z. Okay? And this will be the argument that I want to find. Okay, so this will be the argument that I want to find. Alright? Okay, then to get the argument, I will label it as theta. So to get this argument, basically what I need to do is I have to think some property that we learned earlier, okay, to find out the argument. So such as maybe you can try to observe and see, is there any right angle triangle that you can use, or maybe is there any property of the circle that you can use to find out the angle. So for me personally, I want to use a triangle that can be that is formed by using this line. Okay, so I know that if I have a center to the point that form the tangent with the circle, they are 90 degrees to each other. So this line actually is a tangent of the circle. Okay, then I know that the tangent of the circle and also the line from the point to the center should be 90 degrees. Okay, and then if I draw a straight line from 0, 0 to the center here, it will form a right angle triangle. So this one is for 3. Okay, then the theta that we want to find is this one. Okay, so maybe I put my graph slightly larger again. Then how can I find the theta? Okay, so for this triangle, right, there are a few useful information that I can get. So first of all, I know that the length for this side is actually 2, because it is the radius of the circle, which is 2 unit. So this one is 2 unit, all right, because it is the radius, right, radius of the circle, so it should be 2 unit. Then what else do I have? I also know that the length for this one. What is the length for this line? This is the hypotenuse of the triangle. So the length for this hypotenuse of the triangle, to calculate, you can use the 0.43 and also the 0.00 to calculate the hypotenuse length. So this hypotenuse length, basically it is equals to 4 minus 0 square plus 3 minus 0 square. So by right, you are having the unit 5. Okay, so radius is a 2, hypotenuse length is a 5. Then I can get the theta. How can I get the theta? So to get the theta, right, basically is you will need to add 2 angles together. The one angle is the one inside the triangle. Then another angle is the argument of the 0.43. Okay, the blue color angle here, you can see the arrow that I put in blue, right? So the blue color angle basically is the argument for the 0.43. And then the red color angle, you can use the triangle to help you and find it out. When you add the blue color and also the red color angle, that is how you get the theta, which is the largest or greatest argument for the z. Because your z is here, right? Okay? Yeah, so basically this is what we can do. Okay, so let's have a look for the triangle here. The red color angle, I label it as tau. So from here, right, you can see that if you are having sine tau, it should be equals to 2 over 5. Opposite over hypotenuse. Your opposite is a 2. Okay, then the hypotenuse is a 5. Therefore, your tau will be sine inverse 2 over 5. Okay, so my theta will be equals to sine inverse 2 over 5. Then you have to add the blue color area, the blue color argument. So what's the blue color argument here? So for the blue color argument, basically it is the argument of the 0.43. So what's the argument for the 0.43? Okay, so the argument for the complex number 4 plus 3i is actually tangent inverse 3 over 4. So that's a blue color and argument that we have, or angle that we have. So it should be tangent inverse 3 over 4. Alright, so by using the help of calculator, okay, try to get the answer for this addition angle. So it should be 60.4 degree. Or if you want, you can keep it to 3 significant figure, which is 1.06. Alright, so basically this is how we actually get the greatest argument for the z from 0 plus 0i. Okay, so now we are at question number 5. They want us to find the exact value of this integration. Okay, then let's have a look and see how can we solve this. Right. Okay, so we are given a fraction. Okay, with x over x multiplied with x plus 1 over x squared plus 4. Okay, so first of all, maybe what we can do is like we try to multiply the x inside first. Then I'm having x squared plus 4. Okay, so maybe some students will ask, why do I need to like multiply the x inside? Because at first, if I have a look for the x squared plus 4 as a denominator, it is impossible for us to make it become partial fraction. So we'll exclude the partial fraction integration. Alright, then x squared plus 4 cannot be factorized also, cannot be factorized into any partial fraction. So we need to consider some other method and see how can we further integrate it. So the only thing I want to do is like maybe I can multiply the x inside. I'm having x squared plus x. Then next, maybe I try to think about all the possible, is there any possible way for me to integrate the fraction? Alright, so far we have learned a few type of the basic integration for fraction. So as example, we have learned how to integrate 1 over x squared plus a squared. So we have learned how to integrate f prime x over fx. Okay, or maybe we have learned how to integrate 1 over ax plus b. Oh, but this is not ax plus b, this is x squared plus a squared, right? Yeah, so basically this is what we have so far. Okay, that the fraction that we might able to apply it in this question. Okay, because for our question here, x squared plus 4 cannot be separated into any partial fraction. So I try to consider and see what kind of pattern that I should consider for this integration. So I might able to integrate this by using either of this method. Okay, so I think very obvious. So it is x squared plus 4. So very likely we might need to involve 1 over x squared plus a squared integration in this solution. Alright. Okay, so no matter how, let us try to rephrase it again. Yeah. Okay, so when I'm having x squared plus x, right? Maybe I want to put a plus 4 here. Okay, so maybe I put it as something like this. Plus 4. Then plus x. When I put a plus 4, that means I already changed my equation, right? I changed my expression. So I need to balance it back. I have to minus a 4. Okay, then divided by x squared plus 4. Okay, then what should I do next is I will want to try and separate my fraction into 3. The first one will be x squared plus 4 with x squared plus 4. Then another one will be x over x squared plus 4. And one more, the last one left is 4 over x squared plus 4. Okay, then maybe some of you will think, why should I separate them become the fraction like this? It is because of if I separate them in this way, then they become the expression that we have learned how to integrate them previously. Okay, all these are having a certain pattern of this and this actually. So I will show you here. Okay, so x squared plus 4 over x squared plus 4, of course, you get a 1. So to integrate a 1, it's very easy, right? It's a very direct and simple integration. Then how should I integrate x over x squared plus 4? If you try to investigate a little bit or analyze a little bit, yeah, basically it belongs to f prime x over fx pattern. So I can actually integrate it by using this formula. Then how about for this one? So basically the 4 is a constant, right? It belongs to the 1 over x squared plus a squared pattern. So you can integrate by using this one. So you can see from here, if you try to separate the fraction into 3 different fractions here, basically you can use different technique to integrate them straight away. All right, but of course, this process, you need to think a little bit more. You have to analyze that a little bit more. Okay, because there are not obvious hint, or maybe there's no obvious steps for you, okay, or to lead you to this method. All right, so again, basically you need to think a little bit of thinking so that you can try to rephrase your equation or expression, become 3 different fractions here, so that you can use the 3 basic integration technique to integrate them later. Okay, so this is how I separate the expression. Okay, then after that, we'll try to do the integration slowly, but before that, yeah, I simplify first. This one, of course, like what I told you just now, I get a 1. Okay, so maybe I want to separate them. Easier for me to do the integration later. So for next one, I'm having 0, 6, and then x over x squared plus 4. So like what I told you just now, this one belongs to f prime x over fx pattern, right? Okay, then how can I do, or anything I need to do to adjust it become f prime x over x pattern? So let's have a look here. I will let fx equals to the denominator. So I'm having x squared plus 4. Okay, so what's the f prime x for this one? So if fx equals to x squared plus 4, so the f prime x will be equals to 2x, which means that on the numerator, I want to have 2x. So I can multiply the 2. And to make the equation or the expression balanced, outside I have to divide it by 2 so that the expression is balanced. Okay, then minus, the last term is a 4. I take out the constant 4. Then I'm having 0, 6. Then 1 over x squared plus 2 squared. I want to make it become x squared plus a squared pattern. So it will be 1 over x squared plus 2 squared. Okay, so after I do all the adjustment already, then only I can start the integration. So integrate a 1, I will get x. Integrate f prime x over fx pattern, what do I have? So again, if you can't really remember, then basically you can refer back to the integration formula provided. Okay, but of course, all these are the basic integration. So you're having f prime x over fx, right? Is there any f prime x over fx pattern here? Yeah, this one. So if you have f prime x over fx pattern, when you integrate them, then you're having ln fx. So go back to our question. Okay, so this one is f prime x over fx pattern. Therefore, after the integration, you should have ln fx. Then you put in a 6 and also 0. Then minus 4. Now you need to integrate 1 over x squared plus 2 squared. So again, if you can't remember the pattern, so refer back to the formula booklet. But these are basic one, right? So 1 over x squared plus a squared, you can see it from here. Then by right, you should have 1 over a tangent inverse x over a. So when I integrate back to this part, I'm having 1 over a, which is 1 over 2. Then tangent inverse x over a, which is x over 2. Then you substitute in the value 6 and also 0. Okay, then substitute the value inside. So 6 minus 0 plus half. Then you're having 6 squared, 36 plus 4, ln 40. Then minus ln 4. Okay, then 4 and 2 can be simplified with each other, right? So you're having a 2 here. So you're having a 2, then tangent inverse 3 minus tangent inverse 0. Alright, then again, they are asking for exact value. Therefore, you just try to simplify the term as much as you can. So ln 40 minus ln 4. Ln 40 minus ln 4 can be written as ln 40 over 4. So ln 40 over 4, you get ln 10. Okay, so this whole thing becomes half ln 10. And after that, minus 2, you copy a minus 2. Tangent inverse 3. Tangent inverse 0 will give you a 0. So you just leave it as 0. So by right, you should have -2 tangent inverse 3. So basically, this is what we have as our final answer for this integration. Okay, so this for this particular question, it might be slightly challenging because of you need to think of how to separate this fraction so that you rephrase it becomes something that you can integrate. Alright, so you can analyze or maybe you can try to think about what kind of basic integration have we learned that is having the denominator x squared plus 4y. Then from there, you slowly adjust your equation or expression so that you can integrate them directly. Alright, so this is how we solve question number. Okay, so let's discuss question number 6. Alright, so by sketching a suitable pair of graphs, so highlight the keyword pair, that means you need to sketch two graphs here. Okay, so the equation for this one has one root in this interval. Alright, so basically to sketch a pair of graph from an equation, right? From an equation, you can sketch the one graph from the left hand side, which is y equals to cotangent x. Then another one will be y equals to 2 cos x. Okay, so this is how we sketch a pair of graph. Then we need to have a look at how are we going to sketch the cotangent x. And for this graph, we are interested from 0 until pi over 2. Okay, so cotangent x comes from tangent. So if you still can remember how the tangent graph look like, basically the pi over 2 will be the asymptote. And then the graph of tangent x looks something like this. From 0 until pi over 2. This is the y equals to tangent x. So when you want to draw reciprocal function, what happened to the graph? So for reciprocal function, right, this value here, this part of the graph, okay, this part of the graph is very close to 0. Correct or not? So 1 divided by 0, by right, you have infinity or a very large value. So if I try to sketch my diagram here, how will it look like is, it will become maximum. Oh, sorry, not to say maximum, but it is a very large value, which is something like very close to infinity, or very large value here. Okay, because 1 divided by 0, you should get a very large value. Then, when we are having our original curve, tangent x at this part, this one, okay, you can see that it is very close to the asymptote, which also means that the value of the graph is very large because it's going up, keeps on going up. So the y value is like very large. So we can assume that it is infinity. So when you want to sketch cotangent x, you are taking 1 divided by infinity. When you have 1 divided by a super large value, so by right, you should have a very small value, or you can assume that it is equals to 0. So that means your graph will start from this part and at the 0 here, at the point pi over 2. So the reciprocal function for the tangent x graph will look something like this. Okay, so it should be a curve, right? Okay, so if I draw it nicer, it should look something like this. So this is my y equals to cotangent x. So please label it clearly, alright? Okay, so for me personally, I try to remember the original graph for tangent, then I try to learn the technique of sketching in the reciprocal function. Alright, so we settle the first part of the graph. Then the second graph that we are going to draw is 2 minus cos x. Okay, so how to get the 2 minus cos x? I will start with the graph cos x first. So original graph cos x from 0 until pi over 2, right? Will look something like this. It will start from 0, 1, then the x-intercept will be pi over 2. This is original cos x. After that, I want to multiply a negative to the cos x. That means it is a top, bottom, or up-down reflection. That means originally, if you are having the positive value, it will become negative, and if you're having a negative value, it will become positive. So my graph of negative cos x will look something like this. Okay, then after that, I'm going to translate the whole graph 2 units up. So that means from negative cos x, I want to plus 2. So plus 2 means that I'm trying to move my graph 2 units going up. So I will take the reference point -1 here. If I plus 2, it will start from 1. Okay, Then at pi over 2, you move up 2 units. So that means it might be having 3. Oh, sorry. Is it 3? Wait, yeah, it is 2, sorry. Should it be 2? Yeah, it should be a 2. So that means at pi over 2, your curve will pass through the 2. So that means your graph will look something like this. Okay, so this is how I get my negative cos x. So I'm trying to use a transformation concept that we learned in AS before to sketch a diagram. So if I want to complete the graph here, I'm having a 1. So let's say this is a 2 lah, let's say. So this is the pi over 2. So at pi over 2, my graph will pass through 2 for the cos x, and the graph looks something like this. Okay, so this is y equals to 2 minus cos x. So usually we'll label it very clearly which graph is which one. Then after you sketch the diagram already and sketch the graph already, so we have to actually do a simple conclusion because they actually want us to prove that for these two graphs, right, they are having one root. So one root means one intersection point. So one intersection point is this one. I think it's very obvious. You can see there's only one intersection point, and this value of the intersection point, okay, lies between 0 until pi over 2. I think it is quite obvious, right? So you can make a simple conclusion. You have one intersection point. Okay, then therefore the equation cotangent x equals to 2 minus cos x has one root in this interval. So we are looking at the intersection point, the number of intersection point, and conclude how many roots we have for that particular equation. Okay, then let's proceed to part B. Alright, so for part number B, they want you to show by calculation that the root lies between 0.6 and also 0.8. So for me, I'm going to use the sign change method, sign change rule, okay, to prove that the root lies between 0.6 and also 0.8. To apply sign change method or sign change rule, you have to move your equation to everything to one side. Alright, so everything to one side, which means that y become function fx equals to 2 minus cos x minus 1 over tangent, which is the cotangent, right? So 1 over tangent x. Okay, so you can change it to the other way around, which means that it is okay also if you want to keep the cotangent on the left, then move everything to the right. So it will become negative 2 plus cos x. Okay, so it is okay, no problem at all, right? Okay, then now I want to substitute the value inside the function. So I want to substitute function 0.6 and also substitute 0.8 into the function. Alright, so when you try to substitute them, okay, you can use calculator to help you, of course. Then you're having 2 minus cos x. Okay, so before we do any calculation by using calculator in this equation, right, because our equation involves the trigo, alright, therefore, when you want to substitute any value into the trigo here, all this value actually means radian. So please make sure that you change your calculator into the radian mode. Then only you start substituting the value. So cos 0.6, then minus 1 divided by tangent 0.6. Okay, so you press the equal sign, this is the value that you have. You can see that you're having negative 0.287. Right? Then after that, we are going to do the same thing for the 0.8. So again, I'm having 2. Okay, then minus cos 0.8. Then minus again 1 over tangent 0.8. That's the equal sign. So from here, you can see that I get a positive value now. Okay, so positive value 0.332. Okay, so we substitute these two values and you get the sign change from negative to positive or even from positive to negative. Then basically it means that the root lies between 0.6 and also 0.8. Alright, so if let's say just now you are trying to move the equation in the other way around, that means something like this, then by right, the answer for your f 0.6 should be positive, and this one should be negative. So no matter how you move your equation, right? So suppose you will see one value is positive value and another one is a negative value. Alright, so this is why you call it sign change. So once you see the sign change already, then you can make a simple conclusion. So you can say something like, oh, sign change can be seen, and therefore the root lies between 0.6 and 0.8. Alright, so this is what we have for part B. Then let's continue to the next part, part C. Okay, now they want us to use the iterative formula given like this to determine the root correct to 2 decimal places. Then each iteration should be correct to 4 decimal places. Okay, so to use the iterative formula, right, we need to have the initial value. So what's the initial value? For this question, they didn't inform us, they didn't fix up an initial value for us. So what are we going to do now is we are trying to use or decide one initial value on our own. So to get the initial value, what do I need to, I can actually refer to part B actually, okay, because I know that my root is very close to 0.6 or 0.8. So usually for me myself, I will use all this value as a reference, okay, to decide my initial value. So like 0.6 and 0.8, right? So maybe I will take the middle value, which is 0.7. It is not wrong if you want to take 0.6, and also it is not wrong if you want to take 0.8 or any other value. But usually we prefer to take the value, the initial value, which is close to the root, close to the final answer, so that your iteration won't be too long, right? Okay, so if I decide x1 equals to 0.7, then for x2, how can I get x2? Basically, it means that you have to substitute 0.7 into the iterative formula. So you want to substitute into tangent inverse 1 over 2 minus cos 0.7. Then, of course, we can use calculator to help us, right? So this is a calculator. I want to key in the right-hand side, okay, of this iterative formula. So I'm having tangent inverse. Okay, there's a fraction inside. So 1 over 2 minus cos x. So minus cos x. So for first value that I want to substitute is 0.7, right? So after I key in the formula in the calculator, I press calculate. Then they're asking you, what is the value of x that you want to input or you want to insert? So you should type in 0.7, then press the equal sign. Then from here again, you will see this long value here. They are telling us that every iteration that we get should be correct to 4 decimal places. So I will write out to 4 decimal places, which is 0.6806. Okay, so I'm having 0.6806. Okay, then next one, I want to get the x3. How can I get the x3? You repeat the same process where you try to take 0.6806, okay, key in into the formula, the iterative formula. So I can repeat this by using the calculator where I press calculate again. Then they ask me again, what is the value of x that you want to input? Then you just type in 0.6806. Then you press equal sign. And now you get the second value here, the third value for the x, which is 0.6855. So you can put in 0.6855. Okay, then next one, we continue further. Repeat the same process again. Press calculate. Then type in 0.6855. Then press equal sign. Then you have 0.6843. So you put in 0.6843. Okay, so some students might ask, when should you stop the iteration? Okay, you can stop when you are having the two decimal places answer repeated. Okay, so as an example, if you have a look for this one, 2 decimal places, answer is 0.68. This one is 0.69, right? Correct to 2 decimal places. Then this one is also 0.68. So you can see that all the 2 decimal places answer haven't repeated yet. Okay, haven't repeated consecutively yet. So you have to continue until they repeat. Okay, so I need to continue to get the x5. So again, press calculate, then key in 0.6843, then press the equal sign, then you get 6846. So 6846. Then you double check again. 2 decimal places answer for this one is 0.68. So you can see that 0.68 already repeated for twice. Alright, so if you want, you can conclude this as your root, or you can stop here. But usually for me, I prefer to repeat another one to make sure that it is really the final answer lah. Okay, then I press calculate again, then 0.6846. Then you press equal sign. Okay, then you get 0.6845. So 0.6845. Again, I double check the 2 decimal places answer also 0.68. So you can see that 0.68 has been repeated for 3 times. So I can make a conclusion where the root actually is equals to 0.68. Then again, just a reminder, right? If let's say when you are trying to press the calculator, you didn't get all the answer here that I show you, basically you can double check and see whether have you put your calculator into the radian mode or not. So again, why radian mode? Because for this question itself, it involved trigo and also inverse trigo. So every value that we have here, right, basically means radian. Therefore, your calculator must be in the radian mode. Alright, so this is how we solve question number 6. Okay, so question number 7. Alright, they want us to express 3 theta as 2 theta plus theta, then prove this identity. Cos 3 theta equals to this one on the right hand side. Okay, so since they already give us a hint, right? So we should start from cos 3 theta. And cos 3 theta, I want to express it become cos 2 theta plus theta. Okay, when I'm having cos 2 theta plus theta, right, it is something like a compound angle formula for cos. So it is something like cos A plus B. So your A means the 2 theta, and then your B means the theta. Alright, if you direct compare it like that, alright. So that means how can I expand cos A plus B? It involves the compound angle formula. So if you're not able to remember the compound angle formula, you can refer to the formula booklet. So let's have a look for the compound angle formula here. So for cos A plus B, it should be something like this. Cos A cos B minus sin A sin B. Okay. So this is what we have, cos A cos B minus sin A sin B. So we go back to our solution here. Okay, so if I write out, it should be cos A cos B minus sin A sin B. Apply this formula in my solution. So my A is a 2 theta, B is actually the theta, right? So A is 2 theta, B is theta. Okay, so how can I continue from here is, I will have cos A cos B. So cos A, which is 2 theta, cos B, which is theta, then minus sin A sin B. So sin 2 theta, sin theta. Okay, then next. For the next step, for our final answer, right, we have everything that involves the cos. There's no sign. Therefore, now we need to slowly get rid of the sign, okay? And then if you have a look also for my solution here, you are having everything in theta. But in my step, I'm having 2 theta and also 2 theta. That means I have to expand, right? I have to expand all the 2 theta here by using the double angle formula. Okay, so let's start with this one, cos 2 theta first. So cos 2 theta, I'm going to use 2 cos square theta minus 1. Double angle formula. Okay, so again, if you can't remember what is the formula for cos 2 theta, refer back to the double angle formula, the formula booklet formula, which is cos 2 theta equals to 2 cos square theta minus 1. So why I try to avoid the other two? So I try to avoid the other two because of they are having sign inside the equation. Okay, I want to avoid the sign, right? Therefore, I choose the identity that without the sign one. So cos 2a equals to 2 cos square a minus 1. So that's the reason why I choose like this. Okay. After that, cos theta, I cannot do anything. I just copy it as cos theta. Then for sine 2 theta, if you expand it, you're having 2 sine theta cos theta. Then multiply with sine theta. So again, if you can remember the double angle formula for sine 2 theta, refer it again from the formula booklet. Alright. Then next one, we are going to try and simplify my equation. So I'm having 2 cos power 3 theta minus cos theta. Then for the term here, I'm having 2 sine square theta multiplied with cos theta. Okay, so we are one step closer to the final answer because you can see that, oh, all my angle here are already become theta, no more 2 theta, right? Okay, so we are one step closer. Then now, to get the final answer, so we refer to the answer again. I don't want to have any sine theta in my step or in my answer. So I need to get rid of the sine square theta here. How can I get rid of the sine square theta from this part? So again, you have to use another identity that you learned earlier, okay, to get rid of the sine square. So sine square can be written as 1 minus cos square theta. This is the identity that we learned in AS syllabus before, right? So from here to here, we are actually using the identity where sine square plus cos square equals to 1. Hence, sine square can be written as 1 minus cos square. So this is what I'm using. Okay, then again, slowly simplify and expand your equation here. Okay, so 2 cos cube plus 2 cos cube, you're having 4 cos cube. Minus cos, minus 2 cos, so you're having negative 3 cos. And you can see here very clearly that you successfully get what they want you to prove. Okay, yeah, so this is how we solve part A. Then let's continue to part number B. Right, so when for the first part, right, when they ask you to prove something, very likely you need to use this particular result in the second part. Okay, so let's have a look what do we have in the second part here. Okay, so for the second part, they want you to solve this equation. Cos 3 theta plus cos theta cos square or cos 2 theta equals to cos square theta. So again, this is something that we proved earlier in the first part, right? So that means you need to substitute. Okay, you have to substitute this the result in first part into this term, right? Okay, so we'll start from here. So cos 3 theta plus cos theta cos 2 theta that equals to cos square theta. Okay, they want you to solve the equation, right? So solve the equation means that you want to find the value for theta, and the theta is between first and also the second quadrant, right? Okay, so first I try to substitute cos 3 theta by using the equation that I have in part A, which is 4, then cos power 3 theta minus 3 cos theta. Okay, so this one, cos 3 theta, is this whole thing. The result is from part A. Okay, then to solve the equation, right, you can try to change everything, okay, with cos if you want. Alright, so this is what I can think about it now for now. Alright, so like for this one, I'm having cos power 3 cos theta already. Then for this part, the second term here, I can also make it become, I keep the cos theta. Then for cos 2 theta, I expand it by using the double angle formula. It is okay that if you don't want to expand number, if you want, you also can. If you don't expand, maybe you can solve it later or expand it later. So for cos 2 theta, I want to use 2 cos square theta minus 1. Then equals to cos square theta. So again, now I try to make my whole equation, okay, with cos theta. Alright. Okay, so if I try to label it, this one should be something here. Okay, alright, then I simplify my equation. Multiplying the cos theta into the equation. Then for the right hand side, I move this term over, become negative cos square theta equals to 0. Okay, then what do I have here? 4 plus 2. I have 6 cos cube. For cos square, I have only 1, which is negative cos square theta. For cos theta, I'm having negative 3 minus 1, so it is negative 4. It is equals to 0. Okay, then to solve this particular equation here, you can factorize out the cos theta. Then you're having 6 cos square theta minus cos theta, then minus 4 equals to 0. Okay, then from here, basically you can try to solve your equation already lah. So first equation that you have is cos theta equals to 0. So what is the value for theta? You need to try and consider the cos graph. Okay, so for the cos graph, right? This is the original cos graph. So when it is equals to 0 means that it is at this point. So this one is pi over 2. So the x-intercept is actually pi over 2. Okay, so you want to consider only the answer for the first part. So I shouldn't write pi over 2, yeah, because for this question, they're asking for theta from 0 until 180. So pi over 2 means 90 degree. So I should write as 90 degree. Okay, then after that, I have the second equation here. This is a second equation. So for this second equation, it is a quadratic form equation. You can see that you're having cos squared, which is something like y squared lah. Then cos, it is something like a y. So you're having 6y squared minus y minus 4 equals to 0. Okay, so of course you can try and see whether you're able to factorize it or not. But for this question, we're not able to factorize them. We're not able to factorize this quadratic formula, quadratic equation. So what am I going to do is I have to solve it by using quadratic formula. So it should be negative b plus minus square root b square, which is negative 1 square, minus 4ac. So minus 4, a is a 6, c is negative 4. And I have to divide it by 2a. So 2a means divided by 2 times 6. Okay. Then after that, you will get two values for the cos. Because one is plus, one is minus, right? One is plus, one is minus. So from here, one of the value for the cos is cos theta equals to 1 plus square root 97 divided by 12. Then another one is cos theta, okay, equals to 1 minus square root 97 over 12. Okay, then for this value, I try to get the basic angle. So the basic angle, that means I take cos inverse 1 plus square root 97 over 12. Okay, so maybe you can try like this. Make it into the degree. Okay, so I'm having cos inverse. Cos inverse. Okay, then fraction 1 plus square root 97 divided by 12. Close bracket. Press equal sign. So you can see that this is 25.3. This 25.3, I will call it as basic angle. So I need to go through the first two quadrants and see which quadrant answer I want to accept. For first quadrant, everything is positive, so the answer is basic angle. For the second quadrant, only sign is positive. So if you want to get the answer from this part, you have to take 90 degree minus the basic angle. The theta here, right? The theta here meant for basic angle, yeah? Alright, so just now when I try to press the calculator, my basic angle is 25.3. Okay, so basic angle is 25.3. And I'm looking for cos positive. So for cos positive quadrant, I should accept the answer from the first quadrant when cos is positive. Therefore, my answer for first quadrant is basic angle itself, which is 25.3. Then how about for this second value here, 1 minus square root 97 over 2. over 12, sorry. So you take 1 minus square root 97 by 12. Try to observe the value. You can see that it is a negative value. To get the basic angle, what I do is like, I always make it become positive. Okay, then I will take cos inverse for the basic angle. So cos inverse answer, you'll get 42.5 as a basic angle. So the basic angle is 42.5, right? 42.5. Okay, then now you know that cos is having a negative value, right? So in which quadrant cos is having negative value? So second quadrant, cos is having negative value. Correct or not? Therefore, to get the answer from this part, oh, I make a very big mistake just now. This one shouldn't be 90 degree, yeah? Sorry, this one should be 180 degree. I'm so sorry for that. Okay, so for the second quadrant, you have to take 180 minus the basic angle. So I take 180 minus 42.5, and therefore the data that I get from this part is 137.5. Okay, so compile all the answer together. Therefore, my data is having three different answers, which is 25.3, 90 degree, and also 137.5. Alright, so this is how we solve this question number 7. Okay, so now we discuss question number 8. Right, so it is given that we are having this fraction equals to pi bracket 2 minus I. So from here you can see something with the I, right? So basically you should know that this one belongs to complex number. When you're having x plus yi or something with the I, so it means it is a complex number lah. So a and pi are real constant. So they want you to show that a fulfill the equation 3a squared plus 4a minus 4 equals to 0. Okay, so to get this equation, basically what we need to do is that we have to start from what they give us first. So we are having the equation in terms of a and also the lambda. So 2 plus 3ai divided by a plus 2i equals to lambda, then 2 minus I. Okay, so what am I going to do now is I want to get rid of the denominator. Therefore, I bring it over and multiply with the terms on the right. So I'm having a plus 2i on the right hand side. Okay, so expand everything. So after I expand the two brackets here, I'm having 2a plus 4i, then minus ai, then should be negative 2 times negative 1. So you're having a plus 2. Okay, then after that, I try to rephrase them by having all the real number together. So all the real number together means lambda 2a plus 2. All these are the number or the term without the I. And after that, I'm having also lambda 4 minus a and then with the I. Okay, so I want to rephrase my expression into real plus something with the I. Okay. Okay, so now I want to compare real part with real part and also imaginary with imaginary part. So real part means this one, the part without the I. So it is equals to the 2 on the left hand side. 2 is a real part, right? That means there's no I one. All right. So from here, I'm having lambda, then 2a plus 2 equals to a 2. So you can have one equation in terms of lambda and also the a. So I'm having 1 over a plus 1. I try to simplify them. All right, so this is what I have. Then you need to compare the imaginary part with imaginary part. So compare the coefficient of the I. So you're having 3a equals to lambda 4 minus a. So 3a equals to lambda 4 minus a. This actually means that I'm having the second equation for lambda and also the a. And now, to get one equation in terms of a, right? So we should try to get rid of lambda. So what are we going to do is that we are going to equate the equation number 1 and 2 so that the lambda will disappear. So when you let 1 equals to number 2, right? You're having 1 over a plus I equals to 3a over 4 minus a. Then try to simplify everything. Okay, so move all the, we are having the cross multiplication for the fraction. Then after that, I'm having this. Okay, then try to group everything together to one side. So I'm having 3a squared plus 3a plus a become plus 4a, then minus 4 equals to 0. So this is exactly what they want us to show for part number A. Okay, then next question for part B. For part number B, they want us to find the values of a and also the corresponding values of lambda. Okay, so again, I have to use the result straight away from first part. So from first part, I already know that a fulfill this equation, where 3a squared plus 4a minus 4 equals to 0. To get the value for a, basically you just need to factorize them. Okay, so I should having a 2 here, so 2 and 2, then plus 2 minus 2. So by right, your a is equals to 2 over 3, and also your a is having negative 2. Okay, then after that, you want to continue to get the lambda. So to get the lambda, substitute a equals to 2 over 3 into either one of the equation that you formed just now. You can substitute into equation number 1 or substitute in equation number 2. So after you substitute the value of a, right, by right, the lambda that you get should be 3 over 5. And the same thing happen if you substitute a equals to negative 2, then by right, the lambda that you get should be negative 1. Okay, so this is my answer for the a and also the corresponding value for lambda lah. So when a equals to 2 over 3, lambda is 3 over 5. But if the a is equals to negative 2, then lambda will be equals to negative 1. Right, so this is how we basically solve the question number 8, part B. So question number 9, we are given the diagram. Okay, then they are telling us that the diagram is having this equation y equals to sine x cos 2x from 0 until pi. So that means you should know, right? Start from 0 and then until pi. And the maximum point M where x equals to a. So you can see that you are having a maximum point M here. Okay, the shaded region between the curve and also the x-axis is denoted by R. So you're having a shaded region R. So first of all, they want us to find the value of a, correct, to 2 decimal places. Right, so to find the value of a, it is the x-coordinate for the maximum point. So to find out the x-coordinate for a maximum point, we need to find out dy dx first, and we let it equals to 0 and solve for the x. Okay, so we are having this equation here. So how to find the dy dx for this equation? So you can see that it is actually the product of two different functions, So you're having sine x multiply with cos 2x. So basically it is like having a pattern of y equals to uv, u times v. And to find out the differentiation, basically the concept is to get the dy dx, you copy the u, differentiate the dv. Then copy the v, differentiate the du, or differentiate the u. Okay, so this is what we call as product rule. And for me, I'm looking it as copy the first bracket, differentiate the second, and then copy the second bracket, differentiate the first. So let's have a look here. Sine x will be my first bracket, cos 2x will be my second bracket. So to find the dy dx, okay, so copy the first bracket, differentiate the second. Differentiate cos, you have negative sign. Copy the angle. After that, you need to differentiate the angle here. So differentiate the 2x, you'll get a 2. Okay, so this is what I have for copy the first bracket, differentiate the second. So now I need to copy the second bracket, differentiate the first. So I copy the cos 2x. This is the second bracket, right? I want to differentiate the first. So differentiate sine x, I will have cos x. Let dy dx equals to 0 so that I can solve this equation later. Okay, then before I want to solve this equation, basically what I want to do is like I will want to change it become, I want to simplify it first. So I'm having 2 sine x, then sine 2x, plus cos x, cos 2x. Okay, so far we not able to solve this equation yet. So we need to try and see, is there anything I can factorize out or not from this equation so that I can continue to solve them. Okay, so if I want to try and factorize out something, maybe I need to expand the double angle. So can you see the double angle at this part and also this part, right? So I will want to expand the double angle. Expand sine 2x, I will have 2 sine x cos x. Okay, so again, if you can't really remember that, please refer back to all the identity for trigonometry here in the formula booklet, right? Okay, so for sine 2x, I'm using 2 sine x cos x and expand it. Then for cos 2x, I want to use 1 minus 2 sine square x. Okay, so next step, let's have a look at how our equation looks like. Okay, so from here, you can see that there's a common term that I can factorize out, which is the cos x. If I try to factorize out the cos x, so I'm having negative 4 sine square x in front, and then with 1 minus 2 sine square x at the back. Okay, then if I simplify them, I'm having 1 minus 6 sine square x. Okay, so until this step, basically you need to solve two equations here. So you're having cos x equals to 0. And after that, you also want to solve 1 minus 6 sine square x equals to 0. Okay, so if you try to solve for the cos x, cos inverse 0 for x, you will get the value pi over 2. And then if you are looking for sine x and solve for it, right? So you're having sine x equals to plus minus square root 1 over 6. Trying to press the calculator for sine inverse positive square root 1 over 6, you'll get 0.42. Correct to 2 decimal places. Okay, then for sine negative 1, it will be out of the range because our range is from 0 until pi, which is the first two quadrants. So sine x equals to negative value, it should be in the third or fourth quadrant. So we ignore the answer for the negative value. Alright, we only consider the positive one. So sine x equals to positive square root 1 over 6. So if you take sine inverse, you're having x equals to 0.42. So for these two answers that we get, right, which one belongs to A? So if you have a look for the diagram again, basically A is the first stationary point, okay, for the curve. This is the x coordinate for the first stationary point for the curve. Therefore, when you are getting the value of x, right, there are two values of x, we will accept the smaller one. So the smaller one will be 0.42. Okay, and then we will ignore the larger one. Okay, so we know this one because it is not the first stationary point on the curve, okay, of the curve. Okay, so by right, this pi over 2, it should be actually the x coordinate for this stationary point. Okay, so the smaller value will be the A, which is 0.42. Okay, so this is how we solve part A. And now let's continue with part number B. Okay, so for part number B, find the exact area of the region R, giving your answer in a simplified form. Exact area, highlight the keyword exact area. So to find the area under the graph, basically we need to do integration. We need to apply integration. Okay, so first of all, we have to set up the equation first for the integration. So to find the area, right, I need to know the area start from this point. I need to know what's the coordinate for this one and also what's the coordinate for this one. So both points here basically are the x-intercept. Therefore, I need to find the x-intercept first. Okay, so I'm having y equals to sine x cos 2x, right? So x-intercept means that y equals to 0. Okay, then I'm having two equations here where it is sine x equals to 0 and also cos 2x equals to 0. Okay, so what's the value of x? If you try to solve it, you're having x equals to 0 and pi. And then if you try to solve for 2x, right, cos inverse 0, you have pi over 2 and also 3 pi over 2. Just in case, if you're not sure how to get the answer for cos 2x equals to 0, basically you need to solve it by using the diagram, the graph of cos. Okay, so the cos is having this graph. Okay, then the x-intercept when cos 2x equals 0 is actually these 2 points. So these 2 points will be pi over 2 and also 3 pi over 2. So you actually need to memorize the basic curve that you are having for the trigo. Then for the sine x equals to 0 also the same. You need to remember the graph for sine x. So this is a sine x graph. So sine x will pass through y equals to 0 at 3 point here, which is 0, pi, and also 2 pi. Okay, so for me, I only accept 0 until pi because our range for this question is from 0 until pi. Okay, yeah, then after that, continue further to solve for the x. So the x will be equals to pi over 4 and also x equals to 3 pi over 4. Okay, so which is actually the x-intercept that we want to have actually. So if you refer back to the diagram again, yeah, 0 means this one. The solution 0 is this one. The solution pi is actually this one. Therefore, our solution for pi over 4 should be this point and also 3 pi over 4. Okay, then now I want to set up the integration formula for the area. So how to get the area? You need to integrate from the lowest limit, which is pi over 4, until the upper limit, which is 3 pi over 4. Then the equation sine x cos 2x dx. Okay, but you should aware that from the diagram, right, our area is below the x-axis. So if you integrate it directly like this, you'll get a negative value. For the area, we want to get a positive value. Therefore, I straight away swap the limit, okay, for this integration so that I will get a positive value eventually. So I swap it become 3 pi over 4 and also pi over 4 on top. Okay, so this is the beginning of the step that I want to find out the area. So this is the setup of the integration step. So let me continue with part number B. Okay, so to find out the area, I will want to integrate them from 3 pi over 4 until pi over 4 for the expression sine x and cos 2x. Okay, so what are the methods that we can use, okay, to solve this integration, to get the integration here? Okay, so previously in many of the example, right, or maybe of the past year question that involve the integration, maybe in the first part, the question will ask you to prove some result or something so that you can apply the result in the second part. But for this one, generally they didn't give us any hint, okay, on applying the integration here. Right, and basically there are many ways to integrate this particular function. There are many ways. So I will list out a few for you. Okay, so the first method will be you can use the compound angle formula. Okay, so why can I use the compound angle formula? Because sine x cos 2x, right? It is very similar to the compound angle formula where we expand it, we are having sine A cos B. Okay, so this is something like sine A cos B. So I try to link it with compound angle formula and apply the integration. That's the first method. Second method, you can use the identity sine 3x. Okay, so if you successfully remember this formula earlier, before the exam, then basically you can try to use the identity and solve for the integration. It is because of after you expand this part somewhere else, okay, expand the cos 2x later, you might get a term in sine power 3. So this is how you can try to integrate the expression here. So that's the second method. The third method actually is the integration by part. Okay, so for the integration by part, right, you need to apply it twice to get the solution correctly. Okay, so the fourth method will be integration by substitution. Okay, so all these four methods can be used to find out the area for this particular function. And for me, in this video, right, I'm going to discuss only the first two with you. Because to me, these two are more straightforward. And also you can get the formula. Sorry, the first one is more straightforward. You can get it from the MF19, the formula from MF19. Then for the second formula, for sine 3x, right, if you if you try to remember it earlier before the exam, right, you can still apply this if you want. Basically, the step is not too hard. Alright, then for integration by part and also the integration by substitution, generally I'm not going to discuss it in this video because the integration by part basically is quite long, the step. And also there are some small details that you need to know before you can apply. Okay, so I'm not going to suggest this in the video. Then the integration by substitution also, you need to know how to use a suitable substitution in the step so that you can carry out with the integration. Alright, so if let's say you find that, oh, you are still interested to know, okay, how to use the integration by part and also how to use the integration by substitution for the final answer, maybe you can PM me through the link in the comment that I will put later so that I can send a copy of the solution to you. Alright, so the solution that I have sent to you include all the four methods. But in this video, I'm going to discuss only two of them. Alright, so the first two to me, I think is shorter and also more straightforward. Right? Okay, so let us start with the compound angle formula first. If I have a look for this equation or expression, right, I'm having sine x cos 2x. I try to link it with the compound angle formula, which is sine A cos B. So when do I see sine A cos B? So you can see that I will use sine A cos B in the compound angle of sine. So sine A means the x, cos B means the 2x. Okay, so I'm using this identity or maybe this trigo formula to apply in my integration later. Okay, so let's start. Okay, so I will write the formula beside. Okay, because I'm having sine x cos 2x, that means sine A cos B. I will also having cos A sine B, so cos A sine B. Because the original formula for compound angle formula, right, it is actually sine A cos B plus cos A sine B. So when you're having sine A cos B plus cos A sine B, what happened to the term on the left hand side? It will be sine A plus B. So on the left hand side here, A is the x, right? B is the 2x. I'm having sine. Okay, so I'm having sine x plus 2x. Your A is the x, B is the 2x. Okay, so I will make this as first equation. Then for the second equation, I want to use the same set of identity, but I want to have a minus 1. So when I have sine A minus B, when I expand it, I'm having sine A cos B minus cos A sine B. Okay, so why do I need to consider both both of this set of the compound angle formula? It is because of in my integration, I have sine x cos 2x. And in my compound angle formula, I'm having cos x sine 2x. Therefore, I have to consider both sets so that I can get rid of this cos x sine 2x when I try to combine these two formulas together. Okay, so I want to keep only sine x cos 2x. I want to get rid of this one. Therefore, I will consider both equations here so that I can cancel off the term that I don't want. So I will take 1 plus 2. When I take equation number 1 plus equation number 2, my left hand side, sine x plus 2x will become sine 3x. Then plus sine x minus 2x, I'm having sine negative x. Okay, then equals to sine x cos 2x plus sine x cos 2x, I'm having 2 times of sine x cos 2x. Then this term minus this term becomes 0. So eventually when you're having at 1 plus 2 together, right, this is what you have. Okay, then next one. What is the next step? I will move the 2 over, become 1 over 2. Then I'm having sine 3x Okay, then for this particular term, right? So it should be negative sine x. Sine negative x equals to negative sine x. So I write as negative sine x here. Then equals to sine x cos 2x. And now I can rephrase the sine x cos 2x, replace it by using this particular term, particular expression, so that you can integrate them, because you're having sine power 1 3x and sine x that you can integrate them directly. Okay, all right, so I go back to my integration part here. So I want to basically integrate 3 pi over 4, pi over 4, then 1 over 2 sine 3x minus sine x. Okay, so 1 over 2 is a constant. Personally, I prefer to take it out. How to integrate sine 3x? So integrate sine 3x, you have negative cos 3x. Differentiate the angle inside, you will have 3. So you have to divide it by 3. Then copy the minus. Integrate sine, you will have negative cos. Okay, then substitute in the value pi over 4 and also 3 pi over 4. Okay, so next step, I try to simplify my expression first before I substitute in the limit. Okay, so let's start the substitution. So first of all, substitute pi over 4, which is 45 degrees, into the cos 3x. So 45 degrees times 3, you are having 135, is, if I'm not mistaken, 135. So 135 is in the second quadrant. So in the second quadrant, right, cos 45 will be negative 2 over 2. Of course, you can press the calculator to help you if you want. Okay, then what is next? Maybe I need to move this whole thing down so that I have enough space. Okay, then after that, you have to substitute pi over 4 into the cos x. So you're having plus cos pi over 4, which is 2 over 2. Then you minus. What are you going to minus? So now you substitute 3 pi over 4 inside the cos 3x. So you're having cos 9 pi over 4. 9 pi over 4 is 405 degrees. Okay, so what is the value for cos 405 degrees? If you take 405, okay, if you take 405 minus the 360, you'll get 45. So 405 actually is the same as 45 degrees. Okay, so that means you are looking for cos 45. So cos 45 is in the first quadrant, therefore the value should be 2 over 2. Then after that, substitute 3 pi over 4 inside the cos x. So cos 3 pi over 4 is in the second quadrant, so you're having negative 2 over 2. Okay, so after you substitute all the value, then slowly simplify it. Okay, you have to do it very, very carefully because the equation looks a bit complicated also. So for the first term here, this one, I multiply the constant together. I'm having 1 over 6 square root 2. For this second term, I'm having 1 over 2 square root 2. For this one, again, I take out everything. I'm having positive 1 over 6 square root 2. Then positive 1 over 2 square root 2. Okay, then after that, you can try to simplify all your terms together. So you can treat the third 2 or the square root 2 as an apple. So you're having 1 over 6 apple plus 1 over 2 apple plus 1 over 6 apple plus 1 over 2 apple. So if you total up all these terms here, 1 over 6 apple, 1 over 2 apple, 1 over 6 apple, 1 over 2 apple, right? So by right, you should have 4 over 3 apples. So 4 over 3 apple, we write it like this, 4 over 3 third 2. Then when you simplify it, you will get 2 third 2 over 3. Okay, so this is how we actually get the answer for this integration. But of course, the process, you need to think a little bit more, like how to set up the question correctly so that you can change it, become the expression that you can integrate it directly. Okay. Yeah, so this is what we have for the first method. Okay, so compound angle formula. And this compound angle formula can be found in the trigonometry identity in your formula booklet. Okay, so let's have a look for the second method where you are using the sine 3x equals to 3 sine x minus 4 sine power 3x. So how are we going to solve the question here? Okay, so I will show it here under this part. Okay, so again, we are going to integrate pi over 4, 3 pi over 4 for the function, right? So I'm having sine x cos 2x. Okay, then if I want to integrate this, what am I going to do now is I try to expand the cos 2x. Okay, and I try to expand the cos 2x. Then what do I have here is I'm having 1 minus 2 sine square x. So some students might ask why I need to change it become 1 minus 2 sine square x, because I want to have my equation everything in terms of sine. So you can see that my equation now I'm having sine x minus 2 times of sine power 3x. Okay, so for this first term here, it is no problem. There's no problem for us to integrate this part. Okay, but for sine power 3, we actually not able to solve it or integrate it directly like that. So we have to think a way to change the sine power 3x, okay, into an equation that I can integrate them directly. Therefore, we are using this sine 3x equals to 3 sine x minus 4 sine power 3x. Okay, so if I try to rephrase my equation a little bit, yeah, so I'm having 3 sine x minus sine 3x. Okay, then what is our 2 sine power 3? So 2 sine power 3 here, I'm having everything divided by 2. So I'm having 3 over 2 sine x, then minus 1 over 2 sine 3x. And I will substitute this one into my integration step so that I can continue to integrate it. Alright, so I'm having pi over 4, then 3 pi over 4. Okay, substitute the negative, the 2 sine power 3. So 2 sine power 3x equals to this one, right? So I substitute inside my solution. So I'm having 3 over 2 sine x minus 1 over 2 sine 3x. Okay, then simplify all your term here. So if you try to simplify all your term before the integration, okay, so you can see that, oh, you can combine the sine x together. So sine x minus 3 over 2 sine x, you're having negative half, right? So if you try to factorize everything here, you should have half sine 3x minus sine x, then dx. Okay, so when you complete until this step, right, you can see that basically you can integrate the sine 3x and also negative sine x already. Okay, because these two are the basic function for integration. So this step also similar to what we have on top just now. So you can see that we are trying to integrate half sine 3x minus sine x. So the remaining step will be the same like what I showed just now. Okay, so from this step, you can continue with what I show you in the method just now. Okay, so of course, definitely you will get the same answer, which is 2 square root 2 over 3. Okay, so this method, right, you can use it only when provided that you remember this formula. So for me personally, I don't remember this formula. So what come to my mind is the first method where I'm using the compound angle formula and simplify them. Okay, then again, there are another two methods that can be used in this equation, in this question, integration by part and also integration by substitution. So if you are interested to know the solution, to have a look for the solution for these two methods, kindly PM me through the comment below. Then I can send it to you. I can send a copy of the integration to you for this question. Okay, all right, yeah. So for this question again, when you want to set up the integration step, you need to think a little bit more because the question didn't give us any hint. So to me, the more straightforward one is the combined angle formula. We can directly get it from the formula booklet. All right. Yeah, so this is how we solve the question number 9. Thank you very much. So we'll continue to the... Okay, then let's discuss question number 10 now. We are given the equation of the lines L and M. Then these are the vector equation for the line L. This is the vector equation for the line M. So C is a positive constant. So I think positive constant is quite important, yeah. Okay, so it is given that angle between the L and M is 60 degrees. So find the values of C. Okay, so before we start, right, when we are having two vectors, how are we going to find out the angle between the two vectors, or maybe the angle between two lines by using vector method? So generally it is like that. We are using the direction of the line, the vector, okay, vector P multiply with, vector P dot vector Q. It is equals to the modulus of vector P, modulus of vector Q, then cos theta. So we are using this formula to find out the angle between two lines by using the vector method. Okay, or maybe you try to find out this one by using the angle between the two vectors by using this formula. So same thing happened here because we're having two lines. They are telling us that the angle between the two lines is 60 degrees. Okay, and we want to find the value for C. So we are applying the same diagram, the same formula here, but you need to take note that we are not going to substitute the whole equation into the formula. So for this formula, right, it meant for the direction of the line. So like the P and Q here actually means the vector, the particular vector, or actually the direction of the line. So for your information, direction of the line for line L is this one. So this is the direction of the line L. So for me, I will put it as a P, let's say. Then the direction of the line M will be this one. This is the direction of the line M. So you can maybe label it as Q if you want. Okay, so we are not going to substitute the whole equation in the formula, but we only take out the direction of the line and apply that in the calculation. So let's start. P dot Q means that you're having 1, 1, 2 dot negative 2, 4, and C. And it is equals to the modulus. So how to get the modulus for vector P? So you're having 1 square plus 1 square plus 2 square. How about the modulus for vector Q? It will be negative 2 square plus 4 square plus C square. Then cos theta. Okay, then multiply the dot product means x multiplied with x plus y multiplied with y, which is negative 2 plus 4, then plus 2c. It is equals to, on the right, you're having square root 4 plus 1 plus 1 is a 6. Then this one you should be having 20 plus c square. And cos theta, so theta means 60 degrees, so you put it at 60 degrees. Okay, then after that, what else can I do? So I'm having a 2 plus 2c equals to square root. I multiply the value together, so 20 plus c square. Then this is a half for cos 60. Okay, then again, further simplify them. I try to move up the c to the 2 to the other side, so I'm having this equation. Then after that, to get the value of c, it is quite troublesome if you have a square root, right? The c inside a square root. So we'll want to square both sides. So when I square both sides, I'm having 4 plus 4c square equals to 6, then 20 plus c square. Okay, so from here, try to expand everything and group everything together at one side. Okay, so if you didn't do any careless mistake, right? So you should have this. 104 equals to 0, and hence simplify them further. You're having 5c square plus 16c minus 52. Okay, so I think it's quite obvious, right? This is a quadratic equation in terms of c. So to get the value for c, you can try to factorize them. Then for this one, I have 5c and c, 52, 26 and 2, right? 26 and 2. Then this is negative, this is positive. So you'll get two values here. So c can be equals to negative 26 over 5, but of course we will ignore this answer. Okay, and our second value for C is equals to 2, and this is the only correct answer. Okay, so why do I need to ignore the value C equals negative 26/5? So again, I think the question mentioned clearly just now, where C is a positive constant. So the negative value, we should just ignore it. All right? Okay, then let's proceed to part number B. Okay, so for part B, they want you to show that the length of the perpendicular point from the perpendicular from this point to L is square root 11. So what does it mean? It means that, okay, let's say you're having the line L here. This is the line L. So I'm having a point. So this point is 6, -3, and also 6. The perpendicular distance means from the point to the 90 degree, okay? The 90 degree to the line. This particular distance is square root 11. So they want to prove that the length here is square root 11. Okay, so for the line L, just now in part A, we already have the vector equation, right? So the vector equation for the line L is 3, -2, and 1, just to help you recall back, yeah? Okay, then lambda 1, 1, 2. This is the vector equation for line L. Then I'm having the point. So maybe for this point here, I want to label it as A, easier for the calculation later. And then for this point on the line, which is the foot of perpendicular, I want to put it as F. Okay, so in short, right, for this particular question, basically they want us to find out the modulus or the magnitude of the vector AF. Okay, all right. So let's start setting up the question. So first of all, I want to find the position vector for the F. As what we know, F lies on the line L. Therefore, the position vector for F is equals to is the same like the vector equation line for this line L, because the F is lies on the line. That means if I substitute some certain value of lambda into the equation, into the vector equation, then one of the answer will be the point F. Alright, therefore the position vector of F in general will be equals to the vector equation of line L, where you're having 3 plus lambda, -2 plus lambda, and also 1 plus 2 lambda. Okay, so now my final answer for this question is I want to find out the magnitude of the vector AF. Therefore, I need to figure out what is the vector AF first. So AF means AO plus OF. AO means -6, 3, and -6. Then plus OF means what we have here. Okay, so in short, your vector AF should look something like this. It should be -3 plus T, or -3 plus lambda. I use lambda here, right? Then 1 plus lambda, and also -5 plus lambda. Okay, after this, I know that the vector AF is perpendicular to the direction of the line. So vector AF dot product with the direction of the line should be equals to 0 because they are 90 degree to each other or perpendicular to each other. Okay, so AF is this dot product with P. So what is the direction of the line? Direction of the line, like what I told you just now in part A, it should be this part only, which is 1, 1, 2. So I'm having 1, 1, 2, then equals to 0. Okay, so dot product means x multiplied with x. So you're having -3 plus lambda, then plus y multiplied with y, so plus 1 plus lambda, then plus z multiplied with z, so you're having -10 plus 2 lambda, and it is equals to 0. Okay, so please try to solve for this equation. If you didn't do any careless mistake, right, by right, you should get 6 lambda equals to 12. And therefore, you get your lambda equals to 2. Okay, so after you get the lambda equals to 2, you can find out the vector AF. So what is the vector AF now? Substitute lambda equals to 2 into your AF equation, the vector of AF. So you're having -1, then 3, and also -1. Okay, so the last step, we know that the perpendicular distance, perpendicular distance is equals to the modulus or the magnitude of vector AF, right? Okay, so please try to find out the magnitude of the vector AF. It is 1 square plus 3 square plus -1 square. So from here, I think it is quite obvious. You can see that your final answer should be equals to square root 11. Alright, yeah, so this is how we solve question number 10b. So to find the perpendicular distance, basically I'm using this method where I can see my steps, every single step clearly, like what am I going to carry out. Alright. Okay, so now we are at the last question for this paper, question 11. We are given the differential equation and provided the value when x equals to 1, y equals to 1. Okay, so they want us to solve the differential equation to obtain the expression y in terms of x. Okay, so first we have to solve this differential equation first. After that, rephrase it again, become y in terms of x. Okay, so first of all, we want to group all the x variable at one side and then all the y variable on the other side. Okay, so this is what we have as the original differential equation. Okay, so first of all, I want to separate the x and y first. So before I can separate them, maybe what I want to do now is I try to bring the y over. So if I bring the y over, I'm having negative y squared plus y to the right hand side. Okay, so when I move it to the right hand side, then now I can do cross product, okay, between the two sides. That means dx I can bring it up, then the x squared I can bring it down, become negative 1 over x squared. Then for the y squared plus y, I can bring it to the left hand side, become 1 over y squared plus y, and then dy. Okay, so from this time, you can see that we successfully separate the x and also y variable to two different sides. So after you successfully separate them, you can start the integration. Okay, all right. Then let's look for the equation here. How to integrate 1 over y squared plus y? If you try to factorize it, right, so you can see this one. It is actually 1 over y multiplied with y plus 1. Then, of course, for this one, you're having negative x power negative 2. Okay, so the right-hand side integration is very easy to carry out. Then for the left-hand side integration, since you can see that you're having two linear factor in the denominator, right? So basically, you can use a partial fraction, separate this into the partial fraction before you integrate them, right? Okay, so let's have a look for the partial fraction now. So I will let 1 over y and y plus 1 equals to a over y, then b over y plus 1. Okay, so get rid of the denominator, multiply the whole equation by using y plus 1. Multiply y and also y plus 1. So for the right hand side here, left hand side here, you'll get a 0, you'll get a 1. Okay, then for the right hand side, y and y can be simplified. So a, you need to multiply them with y plus 1. Then for b, y plus 1 and y plus 1 simplified together, then you're having by. Okay, so we need to find the value for a and b. So first, I will let y equals to 0 so that I can get rid of the b. If I let y equals to 0, substitute it into the whole equation here, this one. So you're having 1 equals to a. So very easily, you can get the value for a. Then now, I will let y equals to negative 1. If I let y equals to negative 1, this bracket, right, will become 0, and therefore we can get rid of the a. Okay, when y equals to negative 1, you're having 1 equals to negative b, and b is actually equals to negative 1. So if you try to rewrite your function again, right? So 1 over y plus 1 equals to 1 over y minus 1 over y plus 1. Okay, so I will want to use this result of partial fraction and substitute it into my integration step. I will substitute it here, which means I want to integrate 1 over y, then minus 1 over y plus 1 dy equals to negative x power negative 2. Okay, so we can integrate all the terms here. Integrate 1 over y, you get ln y. Integrate 1 over y plus 1, you have ln y plus 1. Integrate negative x power negative 2, you are having negative x power negative 1 divided by negative 1. Then don't forget about the plus c after you complete the whole integration. Okay, Then I simplify my left-hand side value here. So ln y minus ln y plus 1. I want to use the property of the ln, where if you're having ln a minus ln b, you can combine them, become ln a over b. So I'm going to combine my solution here, right? So if I combine them, I'm having ln y divided by y plus 1. Then equals to 1 over x, then plus c. Okay, next step, we want to find the c. To find the c, we are using the value provided. So given that x equals to 1, y also equals to 1. Substitute into our equation. I'm having ln 1 over 2 equals to 1 plus c. Therefore, my c is equals to ln 1 minus ln 2, then minus 1. So if I'm having ln 1 minus ln 2 minus 1, I get a c equals to negative 1 minus ln 2. The value of ln 1 will be equals to 0. So that's why you left only negative 1 minus ln 2 lah. So I will keep the minus 1 in front so that you won't feel confusing when you see this one. Okay, some students might misunderstand that the negative 1 is inside the ln, where it is not. So the negative 1 here is outside the ln, basically. Okay, then if I try to rewrite my equation again, this is my solution. So I'm having ln y over y plus 1 equals to 1 over x, then minus 1 minus ln 2. This is my particular solution. And now I'm going to rephrase my equation slowly, okay, so that I can get y in terms of x. Okay, so first of all, the ln 2, I want to group them to the left so that all the ln are on the left. So when I take the ln 2 over, it is plus ln 2. So plus ln 2 means you multiply the 2 with the y. Okay, so this one we are using the concept of the property of logarithmic function as well. So basically it's like this. If you're having ln a plus ln b, so you can multiply the a and b together. So when you bring the ln 2 over, you're having ln something plus ln 2, so you multiply the two terms together. Okay, then for the x here, I want to make it become 1 minus x over x, so that it is easier for me to rephrase my answer later when I put it in a fraction form. Okay, so next step, I want to move the ln over. When I move the ln over, it will become e, then 1 minus x divided by x. Okay, then next one, I will want to make my equation upside down. Then I'm having e negative 1 minus x over x. Because we want to make it upside down, right? So the e become the denominator. So the denominator, you're having the negative power in front. So you're having e power negative, then the same power here. Okay, then again, next step, this one, I will want to move up the 2. If I want to move up the 2, then I'm having 2e. Then the negative, I multiply inside so that it doesn't look so complicated. So if I multiply inside, I'm having x minus 1 over x. Okay, so we are almost there. So next one, how can I get rid of the y here? Okay, so either you can make it become 1 plus 1 over y. You separate the fraction, become 2. Then you move the 1 over. Become negative 1. And after that, you cross multiply the two fractions here. So you're having y equals to 1 divided by 2e x minus 1 over x, then minus 1. Okay, so if you want, you can further simplify it, become by separating the power. So you're having 1 minus 1 over x, then minus 1 here. Okay, so the process of simplifying is a bit hard. Not to say hard, but it is a bit complicated. You need to do it very slowly so that you won't do any careless mistake. Okay, if you want to keep your answer in this form, of course, no problem. All right, but I want to separate it so that I can do the further calculation later in an easier way. Okay, then let's have a look for the next question. So for the next question, part B, they are saying, state what happens to the value of y when x tends to infinity. Give your answer in exact form. Highlight the keyword exact form. So x equals to infinity, what will happen to the y? So again, you have to go back to your solution just now. Okay, so maybe I solve the question here for part number B. So for part B, right, they are saying that x tends to be infinity. What happened to the y? If you have a look for here, for the equation here, if you try to substitute x equals to infinity, right, so you're having something like 1 over infinity, which is also a very small value, so we usually assume that it is 0. So from here, you are having 2e power 1 minus 0, so you're having 2e power 1. Therefore, your final answer for the y, right, it should be 1 over 2e, then minus 1. Okay, so basically this is a value for y when x tends to be a infinity value, tends to be infinity. Okay, so y will be closing to 1 over 2e power 1 minus 1. Because you try to imagine here, if you substitute infinity in the x, 1 over infinity, you get a 0. Alright, so this is how we solve the last question here. Okay, so we have discussed all the questions in this paper. Thank you very much for watching the video.